In this video, I want to show you that if you have a small finite domain for a function, then you don't have to specify what the rule is. Now, you might be saying, what are you talking about? And let me try and explain that to you. So, as we've learned, you could represent this function as f from a to b, a being the domain, b being the target, and you might want to write f of x equals some rule here, some rule that tells you what to do to 1. You take 1 over to 10, 2 over to 45, 3 over to pi, 4 to 37, and 5 to pi. But it's really, this is way too much work. You can actually do this, and let me show you how you could do this. How I could possibly specify a rule, but this will motivate why you don't really need to have a rule for this. Okay, the rule that you would specify for this, that you could specify, would be something like this. It would be like a piecewise function or something. So f of x equals 10 if x equals 1, f of x equals 45 if x equals 2, f of, let's see, 45 and then 3 went to pi. Okay, let's put pi. If x equals, let's see, you equal pi when you're 3 or 5. If x equals 3 or x equals 5. And then 37 if x equals 4. And this would be your rule. But what I want to get at is that this rule is really, I mean, there's nothing more sacred, there's nothing sacred about this rule. We could specify all this information just with a table. X, f of x. Let's see, 1 goes to 10, 2 goes to 45, 3 goes to pi, 4 goes to 37, and 5 goes to pi. And so my whole point in all of this is when you see something that looks like this bubble diagram here for a function, if you have a finite number of things in the domain, then this is a perfectly fine definition of a function. You don't need to be thinking to yourself, what's the rule? What's the rule? This is perfectly fine. And if you write it in a table, that's perfectly fine too. You don't need to know the rule.